So I'll just begin. I'd like to welcome everyone to this latest in our sort of international series of seminars. As you will probably know, TAPAS, the project which is looking at air pollution in schools. We've run a seminar series over a number of years, and this one we're focusing on links with international connections. So we're very pleased to have Stefan here today. Just a bit of housekeeping. First of all, this talk is and so forth is being recorded. I hope that's okay with everyone. In contrast to normal, Stefan would welcome interruptions, I think, if there are specific questions towards his presentation as we go along, rather than keeping it all to the end. So please, if you feel free, if you feel that you'd like to say something, either raise your hand, I'll try and keep an eye open for that, or just interrupt, and we'll go from there. So let me first of all introduce our speaker. So Stefan Flagner is doing his PhD as part of the School of Business and Economics, and it's a whole lot of things: Department of Finance and Faculty of Health, Medicine and Life Sciences, Department of Nutrition and Movement Sciences at Maastricht, and he is part of the real estate research team at the School of Business and Economics, and part of the thermophysiology and metabolism at Maastricht University team. So he focuses on impacts of indoor air quality, in particular CO2, temperature and air pollution, on human health, medicine and cognitive performance, which is, of course, very central to the things that we're very concerned with at TAPAS. And he holds 2 master's degrees in the fields of finance and occupational health management, both from Maastricht. So it's a great pleasure to have Stefan here, and I'm going to hand over to him now. He'll share his slides, and as I said, if you want to raise points with him as he goes through his presentation, please feel free to do that. Thank you. So thank you, Stefan. Over to you.
Thanks a lot, Paul. So I will just share my slides. Hope I get the right. You should see the.
Yeah, I can see that. That's good.
All right. Thank you very much for the invitation. I'm really looking forward to that. Because as Paul already mentioned, my topic is about indoor air quality and academic performance, actually. So health is here in this regards more of a mediator, of a mechanism we want to also include later. This is how it started, and then we developed that paper. That's a paper in progress, which also means if you have any questions or any remarks during the time I do my presentation or after I'm done, they're always highly welcome. So I want to give you a short overview first of, I think I don't have to talk so much about the importance of air quality in schools. There is a lot related to air quality in terms of health and sickness absence, especially because of the COVID times, which made it very important. But there are a lot of papers also about air quality in terms of school performance in particular, but also in terms of cognitive performance in general. So the second one, the indoor CO2 concentration cognitive function, is, in my view, an excellent systematic review, giving a nice way and a nice overview to see how many studies actually could connect air quality to cognitive performance in tests of adults, but also in tests for high school kids or for elementary school kids, and also into their academic performance. And then the systematic review by Pavel Vakogi is also very excellent in terms of disentangling the different factors playing a role here when it comes to classroom air quality and children performance in schools. So that was basically the start of my PhD 3 years ago. But two things actually came into, I recognized while I was scanning and reading the literature. One thing is, what is the effect on learning? And what I mean with that is that there are a lot of papers about the effect of air quality at the moment a specific cognition test is done and how that affects the outcome of that cognition test or of that exam grades. But there is not a lot about trying to relate a long-term exposure of air quality on the learning effect prior to the actual exam grade. So that was one of the first thing I wanted to look at. And then the second thing is that, especially when we look at the systematic review of air quality and cognition, we see a huge variation between individuals. So while in average there was a negative effect of air quality on cognitive performance, what was for me more striking was that some individuals might be less affected than other ones. And there are no papers, no lab studies, but also no field studies who try to disentangle and understand a little bit more if there are any individual factors which maybe contribute to kind of a resilience or a higher vulnerability to air quality. So that is exactly what I want to do with that study. So I will look at indoor CO2 as a proxy of indoor air quality, and I will relate that to test scores, but also to sickness absence, because one of the questions is obviously when we have an association of indoor air quality with the test scores, with the academic achievement of children, is maybe sickness absence a mediator of that? So is the air quality affecting the sickness absence, and because pupils are more sick, that's why they have a lower test score? And then the second question I have is, I use overweight as a proxy for health to also see where an individual difference is coming from. So in this case, if overweight as the health status, as a health proxy, can maybe explain a higher vulnerability of indoor carbon dioxide to sickness absence. How do I do it? There are basically two big studies.
Chris has a hand up. Chris, do you want to ask a question?
Yeah, just a question on the sickness absence. How is this defined? Because of course there's lots of reasons why children may be absent through sickness, maybe a broken leg, which might have no kind of connection or correlation to indoor CO2. So I just wondered what is defined within the sickness absence.
That's a very good question. So we are lucky with the data set because the teachers note down when a pupil was sick due to sickness or due to other reasons than sickness. So we could really relate and see the different reasons, saying that, for example, a kid was absent because it went to a family event or to a funeral or anything which is clearly not related to sickness. And then when the teacher knew that this kid was sick, it wrote down also sickness due to an appointment at the GP or an appointment at the specialist, or just sickness. So the data allowed us, and later on in the regression, you will also see that the data allowed us to look at the absenteeism due to sickness and the days being absent due to other reasons than being sick, which, as you said correctly, are not related to the indoor air quality.
That answer your question, Chris?
It does, yes. So yes, thank you.
Good, thanks. Thanks, Stefan.
So the first data set I looked at is that there was an intervention in 7 schools here in the south of the Netherlands in terms of they wanted to change the health and the physical activity level of kids and wanted to see how that affects certain health outcomes like BMI, but also see if dietary behavior is changing. And they did this intervention from 2015 to 2019. So all the health data in terms of BMI, but also in terms of sickness, we have from this data set. Luckily enough, we had an overlap with the other study, which basically looked for each classroom at the environmental data, which is in this case carbon dioxide concentration, fine particulate matter, but also temperature, humidity, and noise. And this overlap is around 1 year. So the data set I use for this study is exactly this overlap of the last year of this health intervention and the first year where we started to collect the air quality data in these classrooms of these 7 schools. And additionally,
can I ask you a question about this?
Yes, please.
So this classroom is ventilated how?
Differently. So there are some rooms which indeed have a mechanical ventilation, and there are other rooms which don't have a mechanical ventilation yet.
Right.
So what we also did then is we wanted to also measure the actual exposure time. So we used carbon dioxide and noise as a proxy to estimate the time pupils are actually in the classroom.
Right.
So for example, if you would have the pupils sitting in the classroom, but they are working on something, then the noise level is very low, but the CO2 level is very high, compared to if they have a break, then noise level and CO2 level is low. So we could see for every classroom, does it have a mechanical ventilation or not? And we could also get an estimation of the minutes they actually spent or being exposed to this environmental condition.
Fine. Okay, thank you.
And then the additional parameter we had is, so the Netherlands has a test score called CITO, and that's basically a standardized test score nationwide. So nationwide, twice a year, every elementary school, which is the first 6 years of school, is having the same test score, because the Dutch government and the Dutch school system, they want to basically check every half a year what's the current status of what pupils should actually know after half a year of schooling, which is really good for us, because that means within this 7 school, we use the test score of this standardized test, and therefore we know that the pupils had basically the same test. Then, as I said, we have absenteeism data. Here I call it absenteeism because we have absenteeism data when they were sick, and we have absenteeism data when they were not sick. And we could split that one. We have the body mass index from the health intervention, and then the class size. Class size not in terms of the cubic meter of the room, but more class size in terms of how many pupils are sitting in that classroom. And then the standard demographic characters of age and sex. The timeline is roughly that, as I said, we have this one school year where we have an overlap of the health data of the one study and the environmental data of our study. So we use the BMI, which was measured at the moment in September, November 2018, because the intervention study measured these measurements every year. The sickness data was then measured throughout the day, which looks like this, that we really have a data set where it's not only noted down that this kid was sick for maybe 10 days in this school year, but the actual dates were also noted down when this kid was sick or when this kid was absent due to other reasons, which allowed us to connect the sickness in the 3 months before the test day to the indoor environmental quality of this 3-month learning period before they do this test. And then the standardized test was done twice a year. It was done in January, February, and in May, June. So coming back to what I said before, we really want to connect more how the absenteeism, the 3 months before, and also the air quality is affecting the learning period before the actual test takes place. But the test itself is also done in the same classroom. So we also have the air quality and indoor environment quality during the time of the test. We have 7 schools, not just roughly, but exactly 7 schools with 75 classrooms and around 1,200 pupils who are part of our data set. The first thing I wanted to give you a little bit an idea of what is actually the indoor air quality in these classrooms. So on the right, you see a graph where each dot is basically one classroom, which already shows that the CO2 concentration in terms of an estimator of air quality is quite different between the classrooms. So while we have quite some classrooms who are below 1,000 ppm, and that's the daily average of the 3 months. So we can really say that this is like the average CO2 level this classroom has, the average air quality level this classroom has the 3 months before the test day. Most of them are below this 1,000 ppm threshold. which by many guidelines, for example, the German Environmental Agency is recommending that 1,000, below 1,000 is good air quality. Above, it's becoming a bit critical. But we also have some classrooms who are really bad in terms of 2,000 or even 2,500 ppm CO2. In the table, the maximum we measured was 2,700 ppm CO2. And that is really 2,700 ppm CO2 as an average of the 3 months. So it's like kind of a constant exposure to this very bad air quality. Regarding temperature and humidity, there is not that much of a variation. Of course, because we have January and February as a testing period, and then we have May, June as a testing period. There is a difference between winter and summer, but not so much actually. The basic modeling we did is that we used a regression model where we had on the left-hand side the test score of this standardized test, and then we regressed the absence due to sickness, but also due to other reasons on this test score, but also our indoor environment quality data, so the air quality, but also temperature and humidity. We have the two pupil characteristics of age and sex, and then we have the class size. Again, the class size in terms of a group size rather than the cubic meter of the actual room. The first thing which we figured out that before we have done any regressions is that this graph shows already the relationship of sickness and the test score. So here it's really the days pupils are sick. And you could see that the higher the sickness rate is, there seems to be a lower standardized test score. But if we run the regression, we get also the same picture. So we could really see in each model, depending on different fixed effect, that the days they are sick is related to the test score they have. I call it here half day sick because we had the case that some pupils were not sick the whole day, but half of the day. For example, they felt sick, so they left only in the afternoon, or they were only absent in the morning. So that's why the data we used is more granular. It's not a full day of sickness, it's half day sickness. And then these coefficients are standardized, which means that an increase of 1 standard deviation in being half a day sick would change the test score, would decrease the test score by 0.04 standard deviations in the test score. We also see that the days being not sick but being absent are also related to that one, which is not surprising because it still confirms that if the kid is not there, it doesn't learn, and that's why it has also a lower test score. But it's more surprising that the CO2 itself, after controlling for various fixed effects, is not related to the test score anymore. So all the literature for now, which could associate the air quality with the test score, this is something we cannot confirm so far, as soon as we add the sickness absence rate to that one.
Can I ask a question about this?
Yes,
test score? So what ages, does every age take this, are included here, or how is this done in terms of age?
So the standardization of the test score is done based on the year you are in the school. So the 2nd grade and the 3rd grade have a different test, which means we control here, we have a fixed effect on test period and a fixed effect on the test domain. So we really compare only the different domains and the different grades with each other and not in between. Regarding the age, so the next slide, we wanted to actually see that. We wanted to see maybe there is a difference in age, which is the second part here, right? Maybe some age groups, for some reason, are more vulnerable to the air quality or sickness or not. And we could see that for the age group of 8 to 10, and for that grade, there is this negative effect of sickness on the test score, but it's not for the younger or older pupils. The same we did also for the test domain, because this standardized test has 3 domains. They test reading, spelling, and math. And only for math and for reading, we could actually find this negative effect, not for spelling. And how I explain that is that if you look, for example, at the systematic review about CO2, air quality, and cognition, they always make this case saying that the complexity of the cognitive task or the complexity of the test is determining how strongly air quality is affecting the actual test outcome. So we try to replicate that by looking at, well, math is more complex than reading or spelling, for example, or it has different cognitive domains which are activated. So maybe they are differently affected by the air quality. Yeah. Then as the next one, so after we found out that sickness is related to test score, but that's independent of CO2, we wanted to see what is actually explaining sickness. And we divided also the group into the normal weight and into the overweight kids. And interestingly enough, if I would only graphically show that, then I can see, at least for the overweight kids, that there is a positive relation of daily CO2, so air quality, and sickness. The worse the air quality is in the classroom, the higher is the sickness rate. For the normal weight pupil, it looks like there is a strong negative correlation. So that's what the graph shows. But obviously, we also run that as a regression analysis. And there we could see indeed that just being overweight itself has a positive or negative effect on sickness absence in terms of it increases the sickness absence. There is one question in the chat, I think, right? Oh yeah, Paul just said, please feel free to ask questions as we go.
Yeah, we've had some people join. We had some people join after we started, and I didn't make it clear, I think, to them that Stefan would welcome questions as we go through the slides. So I just was highlighting that. That's all.
Exactly. We are also having 2 more slides, but if something pops up, then just interrupt me and ask questions. So again, we are now at the stage where we look at what is explaining sickness absence, and we see the overweight itself. So overweight kids are more sick, and the overweight kids who are in a badly ventilated room in terms of higher CO2 concentration are additionally more sick. But CO2 itself is not affecting that, which I find quite interesting because there are 3 past papers who wanted to connect the air quality with sickness. They did it before COVID, but after COVID, we are all aware of that one. And we can here partly confirm that. We can partly confirm that, yes, the air quality seems to have a negative effect on the sickness absence, but it seems to be only for the overweight kids. So it's here also a story of overweight maybe as a factor of reducing resilience towards bad air quality and sickness. So coming back to the initial one, and that's my last slide, basically what did we find? Well, we could not, compared to other studies, connect indoor CO2 or indoor air quality with test scores or with sickness absence, but we could connect and see that higher sickness absence rates are negatively associated with the test score, and we could see that overweight is moderating this effect of air quality on sickness itself, but also overweight is a factor itself explaining sickness absence. This was it. I thank you for your attention. I'm really looking forward to the question, and also thanking to my co-authors, Nicolas Duran from the University College in London, but also Pete Eichholz and Niels Koch as my supervisor from Maastricht University. Thank you very much.
Well, thank you very much, Stefan. And we'll now open the floor to questions. I think Chris, you have one. Would you like to put it to Stefan yourself? I think that would be the best thing.
Hi, Stefan. Yeah, I really enjoyed that talk. It was really interesting to look at things in a long term rather than a lot of these short-term cognitive tests, which are difficult to extrapolate from as to the effect of indoor air quality on cognition throughout the kind of school year. One of the questions I'd got was with regards to the overweight pupils. Are there any socioeconomic links between pupils being overweight that might also be an effect as to why they might perform more poorly in these studies? As to whether, you know what I'm trying to say? There's quite a lot of things that are maybe happening. It's very difficult just to point the finger as it's you're overweight and you're exposed to poor air quality when there might be other issues taking place.
Yeah, that's a good question, because obviously socioeconomic status itself is also connected to overweight and health. We have data for socioeconomic status, and in earlier regressions, we saw that socioeconomic status itself is not explaining the test score, neither is related to sickness absence. The problem I have to say here is that once we add socioeconomic status, we lose a lot of observations, because this is something which not many of the parents reported. So I'm not confident enough to say that socioeconomic status has an effect here. Just because I'm lagging the observation for that one. There is a hint that it doesn't play a role, but in an optimal setting, I would do the whole setting again and have like a clean data set, instead of just using data sets of studies which were there made for other purposes to examine that again. So I can partly answer your question, if that is okay.
Yeah, so I guess the conclusion is we need a lot more studies like this to generate more data.
We need more studies like that, also in terms of, and they have to criticize myself, so I use body mass index as a relation of health, right? We can discuss if the BMI is a good proxy of health, or if overweight itself has specific characteristics to test score or to sickness absence, which other health studies doesn't have. So in an optimal setting, we would have a nice study where we collect socioeconomic status, BMI, but also other health characteristics to really even deeper disentangle what's the physiology behind air quality and test scores and sickness.
Thank you.
We have another question here from Richard Akanet. Richard, do you want to put your question directly to Stefan?
Yes. My question is just asking. I thought I saw in the title there was something about looking at fine particulates. So I wondered if those were measured separately, or if CO2 was just used as representative for the indoor air quality.
Mm-hmm. So we measured it separately. We measured fine particulate matter, PM10, and we measured CO2. And with regards to the regressions we did so far, we could see then only effect of CO2, not of PM itself. So the whole literature stream towards air pollution in terms of fine particulate matter and how that affects cognition, but sickness, we could not confirm it. But it was also not the main focus. The main focus for us was really air quality as an estimator of indoor air quality, and PM it was just controlled for.
Okay,
thank you. Thank you. And Chris has asked, was there a correlation between CO2 and PM10?
That's a good question. I need to check that again. I think there was, but it was very weak. And surprisingly enough, I need to check that actually. No, so then I haven't looked at the correlation between CO2 and PM10. No.
Okay, good. I have a question. As I said, the floor is open if anyone would like to ask questions of Stefan, but I have one while you're thinking of your own. In your presentation, you said one of the questions you were concerned about was why different people have such different responses, why some people seem to be badly affected by air quality and others don't. And I wonder if your study showed much insight into that.
In my opinion, what we could see is that overweight, either itself or as a proxy of health, definitely explains some variation of CO2 on sickness absence, not on test scores. But that gives us already insights, because then it goes into the direction of, well, what is explaining air quality on test scores? It could be the sickness absence and other individual differences between, which has an effect on how much you're vulnerable to air quality, and overweight seems to be one of these effects.
Okay.
Because maybe to add to that, the problem where I come from is also, if you look at the systematic review, from Bowen-Du, which I showed. There are many lab studies, and then they mostly use healthy subjects, or they use even athletes or submariners or healthy office workers. So it's either very specific but healthy population, or it's a normal population. There is nothing done towards, well, do overweight people or people with certain lung conditions like asthma or allergies or cardiovascular endurance or diabetes, any people who have some kind of health conditions, are they maybe reacting differently or even worse to air quality compared to that? So this was not done in a lab setting, as far as I know, and not done in a field setting. And that's why with this paper, I hope to shift the focus more towards also understanding the certain resilience factors, right?
Yeah.
Because we talked about that before. There's a lot of investment in changing the indoor environment, changing the building and the renovation, right? But if we find that there are certain factors which make a human itself also more resilient to air quality, then this is another angle we can intervene and reduce these negative effects.
Yeah, good. Does anybody else have any other questions they would like to put to Stefan? I mean, I'd like to say, of course, that children are a special case in any case. I mean, that's one of the reasons, of course, that we've got a network around school children here in the UK, because we consider them to be vulnerable just by the fact that they're not fully grown, and so their lung capacity and other features of their physiology are developing as they go through from preschool age through school and into puberty and on adulthood and so on. So it's clear that trying to understand the impacts of air quality on this community is quite complex because of the changes they go through during their time at school. And so it makes it especially interesting, I think, from that perspective. I just, if no one else is going to ask a question, I have one more question, which is, you showed a classroom.
Go ahead, please.
With a 3-month average of 2,500 or something ppm.
Mm-hmm.
And did you find anything special about the kids in that? Did you look at that classroom and see, what was causing that, and whether it had any particular negative impacts on the children in there?
I didn't look. So you mean looking at the top 5 worst classrooms, and if there is any characteristic
Something like that.
Explain it.
Yes.
I didn't do that. So what we did is that it could be that they relate all to one school, but because we have a fixed effect on the school itself, so we compare the school within, using the variation within the school, that should not be a problem there. But that's a good idea, actually, to also look at, or ask differently, which characteristics would you expect maybe to see which could explain that?
Well, I mean, I presume that there's rather poor ventilation in the classroom that's associated with that, and you might, I mean, it may be that that you might see some really, I mean, I guess it depends on the age of the pupils in that classroom and what their activities are, but it looks pretty frightening to me to be in a classroom where the 3-month average is 2,500 ppm, and compared with what we all would like, which is somewhere way below 1,000, if possible, I imagine. So yeah. And Chris said the same. It would be interesting to know if that poorly ventilated classroom was naturally ventilated, and no windows or vents were open, or mechanical ventilation where the fan wasn't working anymore. And yeah, certainly, if I was teaching in that classroom, I'd want to know what was going on and want to try and fix it, I think.
Yeah, so we have the data of the classrooms which have a mechanical ventilation. Right. So that's a good point to maybe look at mechanical ventilation as a proxy instead of CO2 for air quality, and see if we get the same results. That's a very good point.
Okay, well, if no one else has any other comments, I'll wrap up. I'd just like to echo Chris and say that obviously this is a very interesting study, and we need more of the same and complementary. But to thank Stefan for a very clear and interesting presentation on his work. And it's good to see from our perspective that there's a big activity in the Netherlands looking at these questions, just as there is here in the UK. So thank you very much, Stefan. And before I close, I'd just like to point to the information in the chat that Kat has put in, that this presentation will be uploaded to our website, and the web address is given there. And if you'd like to join the network and receive our newsletter, she's given a link to that. And I'd like to emphasize the fact that our next Monday presentation will be at a different time. So quite a few of you, I noticed, didn't quite make it at 1 o'clock today. So you've got a bit longer this time. We're starting at 4 p.m. Because the speaker, Olivia Ryder, is based in California, who are 8 hours behind us. So it'll be 8 a.m. for her and 4 p.m. for us. So please make a note in your calendars that the talk next week will not be at 1 p.m. but at 4 p.m. And I think you'll find it very interesting. It's talking about empowering students to make change. And it'll be very interesting to hear what's going on in California. So with that, I'd just like to thank you all for attending, and thank again, Stefan, for a very interesting talk, and good luck with the last year of your PhD and the rest of your career. And I hope you keep in touch with us. Okay.
Thank you.
Very
Goodbye.
much, everyone.